Hello everyone. Today I will be watching a segment from a discussion between Bob Lazar and the NASA engineer who developed Exodus drive. For those who don't know, I already covered it on my channel. It's this engine which, well, depending on the details, which are not quite understood, it's either well, should not work because it would violate momentum conservation, or it works as electron cannon. So it's shoots electron um, um, away and moves as a result. So it's like as a rocket, something like this. Okay, and the discussion which you'll be watching, I guess it happened during some show. Jesse Mitchell's, I don't know. So there is some introduction he includes. I haven't watched the video yet. I only watched like small parts to understand what it'll be about. Okay, so oh,
I mean, at this point, I don't even think it's gravity.
What do you
I think this is another completely unique force. It doesn't behave enough like gravity.
And explain why it's so different.
Like, I mean, because at least my thoughts at this point are, I think gravity is just a property of matter and it's only an attractive force. I'm not sure you can have anti-gravity. Like if it was gravity, at one point, Barry showed me he had one of the emitters it working. He put a lit little kitchen candle right at the focal point and he powered up the reactor and the flame stopped flickering. It stood there frozen in space and time, but I could see the light from the candle. The flame was still visible. Also, he removed the candle and then rotated the emitter. I don't know if it was another direction or more of the same way, but it made a little black ball in the air where no light was escaping, looking like a little black hole. But no, you could just tell there was no light at the focal point right in the air. It was just a dark area. So there it's affecting light, but it wasn't in the candle test before that. So it's a really unusual thing.
Yeah, I don't know. I won't be able to explain any of this. Yeah.
Bob mentioned this anomalous force coming from the craft's emitter. I immediately racked my brain for anyone in conventional aerospace circles who talks about something similar. And then I realized I just interviewed the lead electrostatic scientist at NASA, Dr. Charles Buehler, who talks about something very similar.
Okay, where the heck is this energy coming from? Because if I was to stick this in space, it would accelerate with the power off. So that's
yeah, I don't know. I mean, in what sense it's similar? If he's basically developed something to shoot electrons, I don't know. That doesn't sound like what Bob Lazar is talking about. I don't know.
problem.
You see, there's a long lineage of people studying gravity control, or anti-gravity, in the United States. Perhaps my favorite example is mid-century inventor Thomas Townsend Brown, who discovered that when you apply a high voltage to certain asymmetric capacitors, they produce thrust. That's right, propulsion with no fuel, no exhaust, no propellant, just electricity as the input converted directly into motion. A new model for space propulsion that could eliminate crude chemical combustion rockets forever.
Well, yeah, I actually I read about it. It's basically also, yeah, corona discharge thing. yeah, I looked at it at some point. Yeah, so how it works? It's like two electrodes, yeah, just hanging around, connected by a battery, one big, one small. And I guess, yeah, the conventional explanation, it produces ion wind. So yeah, as you can see, it ionizes molecules near sharp points and edges. And they fly, I guess, from one electrode to another. They become accelerated, and if they miss, this will create some amount of thrust. Yeah, this leaves a cloud of positively charged ions in the medium, which are attracted to the negative smooth electrode by Coulomb force, where they are neutralized again. This produces an equally scaled opposing force in the low electron. Yeah, I don't know. Clearly, some electrons should flying away. Otherwise, the momentum is just wouldn't be conserved, right?
Now you might think that's insane and defies Newton's laws, and I'll spare you all of the corroborating research that I've dug up showing that Brown made real breakthroughs in the world of antigravity. Dr. Charles Bueller at NASA has taken Brown's experiments to the next level. With modern instruments, more rigorous
When we
controls,
see about 0.1 grams, that corresponds to about 1 millinewton of thrust.
and decades of electrostatics expertise from his work at Kennedy Space Center behind him. He's done over 2,000 of these experiments and controlled for just about every variable you can think of. And he's also getting millinewtons of thrust, basically real propulsion with electricity as the sole input. And you can't really argue with his authority to make these claims. The man literally runs electrostatics at NASA. He's the incoming president of the American Electrostatic Society, and he's contributed two fundamental principles to the field of electrostatics that are now widely accepted. So this is kind of an interesting moment in history because we have a man who reverse engineered UFOs, and then we have a NASA lead electrostatic scientist. So I thought I'd just leave it to you guys to kind of nerd out.
Yeah, well, first of all, hi, Charles.
Hi, Bob. This is a very exciting moment for me. I'm a big fan.
Now, the thing about Bob Lazar is he kind of exists on an island. We've never seen him interact with other highly credentialed engineers in aerospace. And what I've learned after spending time with him is he's actually pretty skeptical when it comes to other scientific anomalies.
Man, I'm real interested to hear, your physical experiment setup. Is it a hybrid of your idea and T.T. Brown's, or are you just duplicating one of his experiments? I mean, can you explain to me what it looks like? What's your test setup look like?
Gosh, it's 2,000 variations. I'll try to do my best.
I mean, how is this? I'm sure you've seen the lifter ion motors and stuff along those lines. How is it different from those?
Yeah, actually, that's what was referring to. That's this Brown's what's his name? I forgot. Townsend Brown engines. People build these prototypes. I don't know whether I could find. Maybe, yeah. That's how they look like. I don't know whether you could see something like this. Let's show how to fly. Yeah, so yeah, they fly thanks to ion wind. Fly, right? Yeah, I guess there are different variations. And I think what this, what's his name? Charles Boer build is similar. I described it in the previous video on this topic, where he has this small droplets of a special shape where the end of the droplet is sharp to maximize this effect of producing as ionic wind. Yeah, current designs don't produce sufficient thrust for crewed flight or useful loads. But I think this ion engine is kind of famous in sci-fi. Okay.
A few ways. The ion thrusters obviously use ions in the air to give them momentum conservation. What's interesting about this force, even though it's sort of the same geometry can be used, but at high vacuum, you'll get the thrust. But it's always in the opposite direction of the ion thrusters, which is really cool. Because what happens is you have a sharp electrode in the ground plane. However you do that, you can come up with a million ways to do that. In air, when you do that, you'll break down the gases, either corona or some form like that. In vacuum,
Exactly.
We can actually see these forces arise, but they're always in the opposite direction of the ion wind, which is really interesting.
That is very
It's
interesting.
the same direction as the rocket exhaust. You never think of that naturally. So it really meant.
Yeah, that's kind of weird. I don't know that. Okay, if you continue reading Wikipedia on this topic, they talk about experiments at low pressure, but it's not total vacuum. And the debate is whether the effect becomes stronger in vacuum or weaker. Because in the vacuum, it's easier to accelerate molecules to higher speed. However, you have small numbers of them. Yeah, as you can see, as air pressure is removed from the system, several effects combine to reduce the force and momentum available to the system. The number of air molecules around the ionized electrode is reduced, decreasing the quantity of ionized particles. At the same time, the number of impacts between ionized and neutral particles is reduced. Whether this increases or decreases the max momentum of the ionized air is not typically measured. Also, the force acting upon the electrode is reduced until the glow discharge region is entered. Okay. Experiments have been conducted and found to both prove and disprove force at very low pressure. It is likely that the reason for this is that very low pressures, only experience which used very large voltages produced positive results as a product of greater chance of ionization with extremely limited number of available air molecules, and a greater force from each ion from Coulomb's law. Coulomb law. Experiments which use low voltage have a lower chance of ionization and a lower force per ion. Okay, so that's possible explanation, but it still works in the standard direction. Well, okay, it's not clear. As I said, the electrons have to be leaking for this thing to work, right? Otherwise, yeah, momentum is not conserved. Or the electrons or what, I mean, whatever we have the new current. So I don't know which direction is standard.
Messes with you. So that's what's interesting about it. That's one main difference.
Yeah, that's really interesting. I mean, the fact that it's in the opposite direction of an ion, where an ion thruster would be, and you've done it in a hard or reasonably hard vacuum, and you're getting.
Yeah, that how it could be. If ions fly in one direction, the craft should fly other than in the opposite direction. I don't know.
Measurable thrust?
Oh, we have. We've been doing that since 2020. So for the last 6 years, we test almost every day, probably every other day, different configurations. So we zero in on a configuration, test another concept, and that is an ongoing iterative process. So yes, we have tested high vacuum, 10 to the minus 6 or better. The chip can get up to 10 to the minus 7, but enough to prove to us that there's no ion wind.
What kind of thrust in newtons or grams are you getting?
Well, we're still playing around in the hundreds of micronewtons or millinewton ranges. So I think the highest we've gotten is probably up to the 50 millinewton mark. But that's when we stack these together. We don't learn a lot from them when we do that, other than we can make more thrust, which is important. But we like to understand the thrust density, if you will, of each thruster. So we're trying to optimize each type, optimize each parameter space that we have access to before we can get to larger chambers or outer space to test the mega structures.
Physically, how big are these thrusters?
Oh, they're not very big. They're about 6 inches, maybe 6 by 6, roughly.
Okay.
In that range. It's a nice size. You know, we can make them bigger, but we don't gain anything by that. We just try to keep them manageable so that we can, do different things with them. Stack them, try different voltages, and then we try to measure the currents. We make sure that in many cases there is no current, which is very odd.
Yeah, I would say.
Isn't that interesting?
Yeah, I'd say.
Turn the power source off and it keeps going.
Wait, what?
Yeah, it is very annoying. That in some cases, when we trap the charge in there, that's all that's required. So that really eliminates a lot of things.
So I'll physically.
I'm sure I understand what the setup is. What do you mean, trap the charge there?
The larger one doesn't get you any more thrust, but you can stack them and get increased thrust.
Well, the physical large one will, but we won't learn anything from it. We can do 8 inches or 10 inches, which we have, but we're not learning anything from it. We want to learn, what is the best geometry, shape. We want to optimize. We know area is one of the ways. That will be optimized later once we're in space. But on ground test particles, we're kind of fixed by the geometry of our chamber. Once we get some funding here, Drew does have almost a walk-in size chamber in his garage. You can walk in it.
Wow. Okay.
When that comes online in a few months, then we can test much larger versions of it. So the thrust does depend on the area, it does depend on the volume, it does depend on the voltages, the typical things you would expect. But we try to optimize it as much as we can with the chamber we have actively running right now.
How much are you charging them up to? What kind of voltage are you using?
Well, when we started in 2016, it was at the Townsend Brown level, 150,000 volts.
Okay. Yeah.
Thank goodness we're not anywhere near that now. I think we're operating right now about 400 volts.
You're at 400 volts?
Yeah, so his belief is that it's really Brown thought that the voltage range was, the thing causing the thrust, but Charles's belief is that that's sort of a proxy for electric field strength. And there are obviously other ways to amplify electric field strength at lower voltages. And so he's using 400 volts.
Yeah, but I can't.
Thrust,
It's shocking.
1.5
You're getting
millinewtons.
that's unbelievable. Man, I want to come over and hang out with you.
I can introduce you guys.
Put your hands on it. Do whatever you like. You're more than welcome.
Isn't that exciting?
Yeah. I can't believe you're getting these results, and I can't get past the 400 volts either. If you increase the voltage, you don't see any change in thrust?
Oh, you'll get more thrust for sure. We like to stay 400 volts, 500 volts. We like to stay low if we can.
Okay. Yeah.
It's a preference. We all average, we'll test up to 2,500 volts. We start worrying about breakdown when you get more above that, because these systems are getting much, much smaller. So we don't have access to the higher fields anymore. It's material properties that we have to deal with. But we like the 200-300 volts. It gets rid of other nuances like corona wind or anything like that.
Right. Yeah.
Uh-huh.
All that stuff gets tossed out. And,
yeah, you're not even ionizing the air.
No,
at 400
nothing.
volts. Yeah.
I mean, it's nothing. That's why I was so shocked, because all those other effects drop out right as soon as you drop the voltage down that low, and you can get some cleaner data. Then damn, this is really cool.
We're converting Bob on Townsend Brown.
Yeah.
Well, yeah, I don't know. Indeed, what can I say? He says he obtained this result in his lab, and what it literally violates momentum conservation. Is that what he says? Because I remember NASA was also testing the M drive, and they initially also thought that they had some positive effect, but then it turned out it was like a mistake, an error of measurement. So yeah, I don't know, could something like that be happening here as well? He claims he checked everything multiple times, so I don't know. I would say it would be good if someone else would also check his experiment and do it independently, and then we'll have two different results. Because honestly, I recently read an article about measurement of gravitational constant. It seems like very benign test, and different people already have not agreeing results, even for almost the same experiment. So I wonder what's gonna happen here if somebody tries to recreate it.
Well, thank you for this. Really appreciate it, man.
Good to meet you.
Good to meet you too. Take care, guys.
Take care.
Thank you.
That's really fascinating.
Isn't that wild?
Yeah, it's a little more than just wild.
I know, right?
Yeah, it is. I mean, that's significant.
I think so.
It could really be significant. The thing is, the first thing I would point out, there's something wrong with your test, but not in 1,500 tests.
No.
Yeah, that's exactly what I said, right?
When you've gone through it that many times and have done it for this long, boy, and you've adjusted all the potential parameters and fallouts to
no, I can't. I know.
Yeah, you got to assume that the thing's working.
But you mentioned DC voltage in the craft, and that was that's also a Townsend Brown that is high DC voltage.
Yeah, it's not just high DC voltage. I even mentioned it on Joe Rogan, that I think the material the craft is made from is an electric. And so it always, just like a magnet always has a magnetic field to it, an electric always has an electrostatic field to it.
Interesting.
What does it mean? How does it work? It's like frozen polarization. I just don't know. Yeah, what does it mean? How to achieve it? Interesting. We just Google it. Just don't know. 8. Okay, is that what kind of thing he's talking about? Okay.
And I think that's certainly something important.
Were there high climb rates to the voltage likely? You know what I mean? Like really high climb, like fast, swinging up in voltage.
Oh yeah, I'm without a doubt.
It's so fascinating because
Without a doubt.
it's literally all the Townsend Brown stuff. It's like fast, high DC voltage,
Yeah,
like fast
yeah,
climb
there's-
rates. Yeah,
Well, I wonder if that really applies to the craft more than I was giving it credit for.
I think it does, especially after
It
your
could
conversation with Bueller.
Yeah. I mean, now that's making me wonder. It could very well be, but again, because of the high voltage on the craft and
And it's DC.
Yeah,
So there's
it's
no
DC.
magnetic field interference.
Yeah, right. Man, that's
We're making
possible.
progress live
Yeah.
here.
They
he-
might have been so far past this already, but
Well,
yeah.
the funny thing about Brown is he was looking for a power source that was nuclear for like the rest of his career.
Oh,
He
yeah,
figured out
wow.
the electrogravitics, and then he called it the flame jet.
Boy,
generator.
that would have been the guy to have there other than me.
Well, I mean, you and him. I just
No, you don't need
walk
me.
off set. No, you and him would be.
I just get in the way. But yeah, he'd be the guy to have there.
And you were given some theories, like there being two gravities, gravity A and gravity B. Was that in the briefing documents, or was this told to you?
Actually, I think that was part of what Barry had other lab notes, and I don't know if those were previous documents that he had, but there were lab notes, and this was the direction they were going in at one time.
There are two specific different types of gravity, gravity A and gravity B. Gravity A works on a smaller micro scale, while gravity B works on a larger macro scale. Gravity A is what is currently being labeled as the strong nuclear force in mainstream physics, and gravity A is the wave that you need to access and amplify to enable you to cause space-time distortion for interstellar travel.
Gravity B is like cosmological scale, and gravity A is like subatomic scale. Is that right? Apparently, which it is really interesting.
Yeah, I don't know. He didn't explain how it works, how it's described, right? And why is he calling it gravity, right? Like, is this like, think about it. Isn't gravity uniquely determined by the idea that it's just the curvature of space-time? That's all. There couldn't be no other gravity in that sense. There could be other fields, or the gravity action, Lagrangian, or the equation of motion could be different. I just don't know. It's a kind of interesting. Like we can talk about different photon. Like we have electromagnetic wave is just one vector field. We could have another vector field. We can have another tensor field as well, symmetric to tensor, which will be like metric. But it could not have the same physical meaning, right? So this is a bit unclear.
Because I remember your like kind of OG science tutorial. We were texting about it.
Yeah, the excerpts from the government Bible, the original tape that you did.
And it's amazing. So it sounds like the kind of gravity A is like basically the perimeter
of the atom or what you're dealing with. But
so you have to scale
again,
it up.
I'm just repeating stuff that I was told. It's not like I conducted an experiment to verify that. So,
but it is almost a solution to what has been keeping physics stuck for so long, which is the
possibly
ability to quantize gravity.
Right, possibly.
That's so
possibly,
interesting.
if in fact that's gravity.
Have you ever, we were talking about this, but gravity-like fields, and I want to give this to you because you can make sense of it more than me. And we were talking about this last time.
Oh, yeah.
This is this guy, Burkhard Heim. Have you ever heard that name?
I've heard the name, but I don't know anything about him.
So he, at the age of 19, became deaf and blind due to an explosion.
Oh.
And he was a German, and he ended up moving over to the U.S. and working for Lockheed Martin in the 50s and was renowned as just a total genius. And he had a really interesting theory of gravity, which involved, I guess, two gravitational fields and like some of these like subcomponents of gravity. I wrote this down because it's honestly beyond my pay grade. Gravity breaks down big and small scale. So it could be gravity A and gravity B.
Yeah.
Specifically, standard gravity, G, is the tensor summation of three gravitational components. Gg, which big G, little g, which is scalar gravity propagated by the graviton.
By the graviton, so he's going with gravitons.
For that.
Okay.
GGP, dark energy / matter propagated by the gravitophoton. And GQ, vacuum field, a repulsive force propagated by the quintessence particle. So in addition to the standard four forces, gravity, electromagnetism, strong nuclear, and weak nuclear, EHT, which is extended Heim theory, which is named after him, adds two previously unrecognized gravitational forces, which brings us to 6 fundamental forces.
Wow.
Yeah, I'm confused. So you basically said there's additional scalar and what vector, which you just called part of gravity, right, or something. I don't know. What's this guy name? What? Burkhard Heim. I never heard about him, but if there is a review, okay. Okay, so that's his development of unified field theory. Heim Theory. So that's how it's called. Okay. Well, is there any like an article or something we could read? Okay, no, I don't know. Guess we have to basically ask AI or something. Is there any way we could actually just get to Gemini? I just don't know. Okay. Now. Okay. Well, guess how long it will take him. I should have probably think about it all in advance, because that's probably will be difficult. This is kind of too generic. Heim Theory begins with the smallest indivisible unit of area, quanta. Okay. Metron. So it's high dimensional theory. Discrete area quanta. Okay. Okay, 6th dimension. Later 8 or 12. That's like almost more than more than M theory. Okay, without special dimensions in string theory, they are explicitly linked to physical work, entropy, and information. So it's kind of non-standard, yeah. He for some reason he quantized area. Why? Okay, at least he has variables, standard coordinate variables. Additional variables are basically labeling entropy. Polymetric tensor. Okay. So what is this indices IK? Didn't explain. What is this? What's CI? Okay, phi IKL is like connection. What? This is very interesting. In the 70s and 80s, Heim theory garnered brief attention because computational runs of his mass eigenvalue equations appeared to predict the masses of non-elementary particles with astonishing precision. Our subsequent review by theoretical physicists revealed that the mathematical derivation relied on a flawed application of a spherical Laplacian operator. I don't know how you could mess up this, rendering the highly accurate mass predictions coincidental. That seems unlikely, or mathematically reverse engineered. But which one is it? Like, I understand, was it hard to figure out? You know, it should be very easy to understand when somebody's just trying to obtain the result he wants in advance. What is this? Okay. Tons. Yeah, never was detected. Okay, this is a weird story. Some gigantic article. Oh, yeah, I guess you'll not be able to read it for free. Well, I guess that's all we could learn today about it. I don't know. Unlikely we're able to study all these new equations. It's a completely different approach. Figure out what's wrong there. So, but I mean, if it doesn't have experimental verification, how much time should I spend on it? Okay, where we stopped? I don't remember. Somewhere here.
Nuclear and weak nuclear. EHT, which is extended Heim theory, which is named after him, adds force propagated by the quintessence particle.
Yeah,
so in addition to the standard four forces, gravity, electromagnetism, strong nuclear, and weak nuclear, EHT, which is extended Heim theory, which is named after him, adds two previously unrecognized gravitational forces, which brings us to 6 fundamental forces.
Wow.
And what I find interesting about that is there's Amy Eskridge is this anti-gravity researcher who actually died under very mysterious circumstances. And she apparently was, at the end of her life, kept talking about a 6th force. That was like
a 6th force,
sixth force, yeah.
The 6th force is anti-gravity. That's what my group has a mathematical equation to physically describe. We have 6th force on lockdown.
And so I wonder about, this book, and there's these two guys in Germany who are very high conviction in this extended Heim.
I'd like to read it.
Well, it's yours.
Well, thanks.
Yours.
Oh, that's really interesting.
Isn't it interesting?
Yeah. I'm also on that. I think it was not gravity. I don't think it is. I don't think it's gravity.
Yeah,
it's
something else.
It's something else.
No, it's like floating speculations. Yeah, how could that? The problem with Bob Lazar, he hasn't never brought anything which you could test. That unfortunately, like there was this element 115 prediction, but he wasn't able to find a stable isotope. Like, the problem is, without the knowledge about the number of neutrons in it, we don't know which one of them will be stable, right? And I think he didn't tell. So, like, we know the island of stability should be somewhere there, but where exactly, it's unknown. So, where is this crucial information?
Yeah, something else going on. Yeah. Because if it were gravity well that you'd normally see, it's a little black hole, little gravitational source. You'd just see everything getting sucked into it, no matter what.
Other things would have acted differently too.
Yeah, light lensing and
yeah. So it
almost feels like
it almost has to be. It almost has to be.
It's almost like it had root access to reality itself, like it froze time.
So Jonas, what are we launching today?
We gave cursor agents their own computers, and now they can test.
Yeah, but if it froze time, how come the photons were still coming out of it? You see a glowing candle, it should be dark.
Can it freeze time in some local space?
But still,
Confine it.
Still, the photons are flying out.
Yeah.
Or maybe, and if you say, well, it doesn't affect photons, how come it made the black little ball? So.
Yeah, okay. I don't know, indeed, but why? What he described with a candle is very weird. Because he said the candle is now still. So what does it mean? The candle fire, right? There is no air movement. But the fire itself is just plasma. Yeah, it doesn't make sense. I don't know.
Where do you think? Would you have a best candidate for what it is?
No.
There is.
No, that's why I think, I mean, I lean towards this is another force, and just stop calling it gravity. But
do you think it's
as Barry said, the only thing we know that does this is gravity, so we're calling it a gravity generator. Okay. Yeah.
And then and it's being created ostensibly due to this proton bombardment of element 115, and then
possibly
you get 116, and then you get a decay, and then
if in fact all that's occurring.
Yes.
Yeah.
Oh, it's so interesting.
I mean, don't forget that in the film we did not include the mechanical watch experiment that was also conducted in the lab. So there was the candle, the black ball, and the mechanical watch. We didn't put it in there just because we wanted to shorten the film. But there was another experiment, Bob, remember? And there was like a mechanical watch that just stopped clicking.
Yeah.
I mean, that's another indicator where Bob said,
just like I mean, it's kind of similar to the candle. It just stopped, but I could still see it.
Yeah.
It's like it's freezing time.
It's freezing movement. But not affecting anything else. There's nothing that just freezes a movement.
No, it doesn't. But that is really, time is so weird because we only
something that inhibits kinetic energy,
right?
Which would be that.
But that would affect the flame too, right?
Would be really weird.
Well, it's so weird, especially given all of the forms of possible kinetic energy. You're talking about a watch, a mechanical watch, and a flame are very different things.
Yeah.
So that's so strange.
Okay, I guess at the end. Yeah, I don't know. I don't know what to make out of it. The Bob Lazar by itself, like, was never, entirely reliable person. Right? I don't know that his accounts were never corroborated by anyone, and his story about his records disappearing from MIT and Caltech are kind of questionable, right? And the fact that nobody there remembers him is also strange. And the fact that he was working actually, somewhere in Los Alamos as some sort of contractor for minor, something insignificant, minor job, kind of makes us even more skeptical of his story. So I don't know, like, should I take it seriously or not? Only if yes, of course I could not explain the things either. Now with Exodus Drive, I already told you what I think. I personally thought it's like ion wind. Otherwise, it violates momentum conservation, and I don't know how it could work exactly. Yeah, that's kind of mysterious, and I think it would be great if the experiments of this NASA engineer would be replicated by someone else, because I just said I had many other instances not related to any alien or UFO where just people were wrong in their simple experiments. Like, it's not that uncommon or like terribly unusual, right? Even with NASA's testing of M Drive that happened, they originally thought there is some trust But eventually the signal disappeared, right? So yeah, I don't know. I don't think I could reverse engineer how UFO flies based only on Bob Lazar's accounts. Yeah, but that's a still interesting story to follow. So I hope I'll keep you updated.